Function notation and evaluating functions. F of x is another way of saying y. F of x is read as f of x. This is function notation. To evaluate a function, all you do is substitute. Evaluate the function f of x is equal to negative 3x minus 7. So here we have f of 0, so that means we substitute 0 into x into this function here. So negative 3 times 0 minus 7. 0 minus 7. So f of 0 is equal to 7. So when x is 0, y is negative 7. F of 2 is equal to negative 3 times 2 minus 7. That equals minus 13. So f of 2 equals negative 13. F of negative 5 is equal to negative 3 times negative 5 minus 7. 15 minus 7, 8. F of negative 5 is equal to 8. So in this instance, all we did was substitute the number that's with the function in the function notation for x. This is a rather simple function, so we could do this probably just using mental math. Another way you can do it is by the calculator. So here we have the function negative 3x minus 7. So I'm going to go into y equals and type in negative 3x minus 7. Okay. And I'm going to graph that function. And I'm going to see what, if 0, negative 7 is a point on this line. So I'm going to hit trace. I'm going to type the number 0 and hit enter. And 0, negative 7 is a point on this line. So this is correct. F of 0 is equal to negative 7. How about 2? I'm just going to type 2 and hit enter. 2, negative 13. F of 2 is equal to negative 13. Negative 5, enter. Negative 5, f of negative 5 is equal to 8. So that's how you do it on the calculator. In this case, with such a simple function, you could choose either the calculator or by hand. Alright, given the function f of x is equal to 2x squared minus 5x minus 3, find the range if the domain is negative 2, 0, and 3. So what they really want is f of negative 2, f of 0, and f of 3, using this function here. Well, we have two x's in here, an x squared and an x, and certainly we could compute this by hand, but I think the best way to do it would be to use the calculator. So I'm going to go into y equals, type 2x squared minus 5x minus 3. Hit graph, trace, and now when x is negative 2, y is 15. So when x is negative 2, y is 15. And when x is 0, y is negative 3. And when x is 3, y is 0. Okay, we're going to be identifying a function on a graph. So in order to replicate this graph, you need to plot these points. All right, given the graph below, find the following. F of 3. So when x is 3, what is y? That's 4. F of negative 2. So when x is negative 2, y is 1. Find x if f of x is equal to negative 6. So if y is negative 6, what is x? 1. Find x if f of x is equal to negative 2. If y is negative 2, what's x? Negative 5. Graph the line y equals 2/3 x plus 2. So we start with the y-intercept, and we plot our line. We put a point, and then we go up 2 and over 3, up 2, over 3, up 2, over 3. Oops, this should be over 1. All right, and then down 2 and over 3, down 2 and over 3, down 2 and over 3. Draw a line. This one's going to be, should be over more like that. There we go. Not good at that yet. Here are the points. All right, now we've graphed that line, and we're going to answer these questions here. F of 6. So when x is 6, 1, 2, 3, 4, 5, 6. Y is 1, 2, 3, 4, 5, 6. Y is 6. When f is 0, y is 2. If y is negative 4, 1, 2, 3, 4, then x, I believe, is negative 9. And when y is 0, x is negative 3. So that's the reading it from the graph. And of course, you certainly could have put the function in if you do the equation of the line. 2/3 x plus 2. Hit graph. Trace. Typed in 6. 6, 6 is a point. F of 0 is 2. F of negative 9 is negative 4. And f of negative 3 is 0.